Boom.
Good morning, ladies and gentlemen. We're going to do this now. Sketch a circuit that includes a battery, bulb, ammeter, and voltmeter using the proper symbols.
Yep, you got to wire everything the way it's supposed to be wired. On your mark, get set, pause this video, do this in your notes. Go!
Okay, so we got battery. That's the positive side.
All right, here we go.
That's the negative side. That is the positive side. Okay.
Yeah.
And then we need a bulb. I'm gonna put the bulb right here. And then we need an ammeter. I'll put the. Well, actually, I like doing the ammeter in pink. Okay, so I'm gonna go ahead and connect these guys right here. I'm gonna leave a spot over here for the ammeter and the flow. I've developed a system for the colors I like to use for certain things.
Oh yeah, that's normal.
And the voltmeter, we're gonna connect it to we're gonna read the voltage drop across the bulb.
Yeah.
Oh, and I forgot to put the circle around the bulb. Like that. Okay. Sweet.
All right. Okay, so what I would do is 1 point for the battery, 1 point for the bulb, 1 point for the ammeter in the circuit, and 1 point for the voltmeter wired across the bulb.
Now, if you put the voltmeter across the battery, is that the end of the road?
If you did that, then and not the bulb, 1 point.
Yeah. And if you put the ammeter here or here, it
Doesn't
doesn't
matter.
matter. It
As long
just
as-
can't go here, or yeah, that doesn't help.
No.
Okay. All right. So our equation for current is charge over time, coulombs per second. Oops. Shh, don't yell at me. Oh wait, a battery in a simple circuit lights a bulb for 2 minutes and transfers 8.4 coulombs of charge. How much current flowed? Okay, so our time is 2 minutes. How many seconds is that?
That's 120.
Okay, 120 seconds. And our Q is 8.4 coulombs.
Yeah.
Okay, and we want to know how much current flowed. We could just use our handy dandy equation here. 8.4 coulombs divided by 120 seconds. Ooh, is it working? Have it ready? Okay, 8.4 divided by 120, and I get 0.07 amperes.
0.07 amperes.
Okay, 0.07 amperes. Boom. Okay, so how much current flowed? That
You
much
guys
current.
able to do this stuff, folks?
Easy peasy, do my sleep. Okay, if a battery can sustain 0.15 amps for 2 hours before dying, how much charge is transferred, that whole time?
Go ahead and do this on your own, boys and girls. See if you can do this out.
Give it a shot.
Amps are the units of what?
Current,
Hours are the units of what?
time.
And what are we trying to solve for?
Ghostbuster. I'm just kidding. Charge. Okay, who are you gonna call? Okay, time is 2 hours. We said that was 120. 2 hours.
2 hours is 60 times 60 times 2. That's 3,600 times 2. That's 7,200 seconds.
7,200 seconds. I'm going with it. If it's wrong, you guys.
You gotta need
Blame Mr.
another. You
Boykin.
need another zero. in
Oh,
there.
sorry, you said 7,000?
7,200 seconds.
Boom, there we go. Okay. And then how much charge is transferred? Don't forget, charge is our Q. Okay,
So I is Q over T. How do you solve for Q?
it.
It.
Multiply by T on both sides, right?
It.
Okay, so the charge is equal to it. Like the scared clown. Never seen the movie. One day I will. Okay.
Not me. I got no use for that.
72. I'm really not a scary movie person, but ever since I watched American Horror Story, I crave the thrill.
Oh yeah.
Okay, so 0.15 times 7200. Okay, so I get 1,080 coulombs.
1,080 coulombs. And remember, an ampere is a coulomb per second times seconds gives you coulombs.
Coulombs. Yeah. We're really coulomb per second. Cancel. Okay.
All right.
All right, so.
You guys are getting a handle on this.
Oops. Wait, wrong way. Right there. Okay. So, important terms. Circuit. Do you know what a circuit is?
It comes from the same thing as circle.
Oh, nice. Okay. Do you know what current is?
Well, it's
Cool.
charge flowing in a circuit.
Yeah, in a certain amount of time. Okay, let's see. Let me just charge, you know.
Yep.
Potential difference. That's that delta V thing, right?
Yeah, that's the
Volts.
difference in electrical potential energy from one side of an item to another side of an item.
Okay. And power.
Power is the rate at which work gets done. Power is the rate at which energy is changed from one form to another.
Okay, and two things that we need for power. We talked about that already, right?
Yeah, we have yesterday.
Power, we always say power is intravenous, or IV.
That's right.
Current times potential difference. Okay, ammeter measures current. We've got a pink one in our circuit over there. It must be part of the circuit in the flow.
Got to be in the flow. That's right.
A voltmeter is wired across an element as such.
And that's what we mean by across, from one side to the other. It's measuring the difference in electrical potential energy.
And how can we say across an element? This is a bulb.
Well, we could an element of a circuit is any part of the circuit.
There
we
could be other things.
You know, you could measure the potential difference across the battery.
Oh, okay.
You could measure the potential difference across the wire.
Ooh.
Ah.
Okay, so that's what we mean by element there.
Yeah.
Okay. Why was the bulb? Oh wait, I forgot where I'm at here. Oh yeah. Okay, so why was the bulb brighter with two batteries yesterday? Do you guys remember yesterday?
We went from one battery to light the bulb, two batteries light the bulb, and the two batteries is brighter. ¿Por qué?
Yeah. What? So.
¿Por qué no?
Why is that? What do we have? What two things did we measure yesterday?
Well,
We measured our current.
measure the current,
Okay. Measured our current, and we measured our.
potential difference,
I
or
don't
voltage.
know potential difference there. So, what do those two things get you? More current and more potential difference.
We got more current and more potential difference when we did that.
It was more brighter. So when we added the more voltage. Okay, so what does that mean? Electrical power is how much current is flowing across how much potential difference. So when we had more current and more voltage, we
Yeah.
had more power.
And that was your homework last night, is using this equation. And what's going on with electrical power? Electrical energy is being converted from one form to another.
Oh.
Yeah.
Okay. Like into light and heat and whatnot?
Yes, ma'am.
Oh, okay. All right. So, David Bowie. We're gonna have to pause on this one. Let's go ahead and take a look at our lab. Normally Mr. Boykin would play David Bowie changes, and it really just builds.
If it takes too long, we're not going to play it
It's
now.
like a minute. Yeah. So we're gonna go ahead and take a look at the lab that we've got over here. Changes. Okay, so the purpose here is we're going to observe and measure the properties of simple circuits.
That's right. This is a very important lab. There's several trials, and one thing, what you're going to be doing is...
You're going to be recording and observing the ammeter readings, the voltmeter readings, and the bulb brightness.
Yeah, that's a judgment you make. When you look at the bulb, how bright is it? And it's how bright is it in relation to the other situations.
Okay, so let's take a look at this. Want to go over there? Okay. So we've got two cells, two batteries. We've got a round bulb, that's this guy right here, and we've got an oblong bulb.
Yeah.
What's
And
the
if you don't know what
difference?
oblong means, it's not round.
Yeah, it's just the opposite of round. Well, not the opposite, it's just not round. Okay. The bases, that's what these are in, and then the jumper wires. Okay.
Well, I just realized oblong is like tic-tac shape.
Oh, yeah. When you're eating a Tic Tac, you're eating an oblong shape.
That's right.
I feel like oblong is just fancy.
Yeah.
Okay, so trial one. So round bulb, that's this one. One cell. So one of these. I'm gonna put these two over here.
Yeah, batteries are called cells. It's an antique term. They used to be called dry cells because there were wet cells. Yeah, well, some of us are old.
Okay, so using one cell, light the bulb. Measure the current in the circuit, measure the potential difference across the bulb. Okay, so I want to make sure my ammeter is in the flow, and I want to go from the black side of this, the negative side, through like this. I know, usually you guys are here to play with this stuff, and it's really fun.
You be doing it yourself, so.
Okay, so we're gonna hook this up in a second, but I also need to include my voltmeter in here. Now don't forget, there's 3 things you guys need to be looking at. The brightness of the bulb, so make a mental note of that. And then the voltmeter, so we'll write that information down.
So be prepared, you got your lab there. Be prepared to take data. We're gonna fly through this sucker.
Okay, you ready? You ready? And hopefully I can, oh.
Bulb lights up. The current is about 160 milliamps, and the voltage is about 1.1 volts.
Okay, so you said
60 milliamps.
160 amps, and you said how much was the potential difference?
1.1 volts.
1.1 volts. Was that right?
Wait a minute.
Did you say 1.6?
No, do it again. Let's see.
Sorry, guys. We thought we were gonna fly through it.
Okay, that's 1 volt. There's 2 volts. It should be 1.5, but we got 2. So go ahead.
So sorry, I'm upside down here. You said 1.1?
Yeah,
good?
No, it was 1.0 volts. You know what?
1.0.
Hang on a second. I have a battery tester. I wonder if that battery is weak. This is a marvelous thing right
Oh
here.
yeah, let's try this out. Okay, so we can go ahead and tell them what this is. I think you.
It's a battery tester and what you want.
Am I getting it in there? Help me.
Here.
Here, give me this. Watch the pro do the job. Do it.
Yep, it's good.
Okay.
Can't explain it.
Yep. These things happen. Okay, so we said 1 volt exactly.
Yep.
Okay, 1.0 volts. Okay, my paper looks like this. All right. Oopsies. Okay, so now, and then the brightness. How bright? It wasn't very bright, right? It was just kind of like, it's kind of like, kind of sad.
Yeah, not very bright.
Sad bulb. Okay. All right. So round 2, round bulb, but 2 cells. Okay. Oh, you know what? Not that it matters too much, but.
It does.
Okay. Here we go.
That bulb is definitely brighter. Now we've got 2.5 volts, and we've got about 290 milliamps.
Okay, 2.5 and 290, so.
290 milliamp, 0.290 amperes. And the bulb was brighter.
Oh yeah, so we're gonna say brighter bulb, I'm gonna say.
Brighter than trial 1.
Okay, so mine looks like this. All right, should we talk about this question real quick?
What differences did you observe between 1 and 2? Well, they were brighter.
Okay, so
2 was brighter.
So trial 2 was brighter. What else?
Well, look at your numbers.
Okay, so we've got more current and more voltage for both of them, right?
Oh.
Okay, so trial 2 equals more current and more voltage. I'm gonna write it like that.
That'll work.
Okay.
Boys and girls, you put it in your own words.
So trial 3, switching out to the oblong. I'm just gonna put you in here, mother. There we go. Okay, so I'm just swapping these guys out. Okay. So using 1 cell, measure current in the circuit. Same thing, right? Okay.
Yeah.
Okay, so here we go. I'm gonna go ahead and touch this here and touch that there.
It's lighting up, and we've got about 1.4 volts and about 50 milliamps.
Okay, so 1.4 volts and 50 milliamps. That's going to be 0.050?
0.050 amperes.
Amperes. Okay, moving that decimal over 3 spots to the left. Okay. Oh, and then the brightness, it was similar to number 1, right?
It's hard to tell without them side by side.
Yeah. Okay, so it says what was the same and what was different between trials 1 and trial 3. Okay, so let's take a look at trial 1 here.
1 bulb, 1 battery.
Okay. Well, look at the current. It's a little less current. That's weird. If it's just 1 battery, the only thing we changed was the bulb.
Yeah.
So trial 3 was less current was measured.
Yeah, we're also seeing more voltage in trial 3, but I'm something tells me that there's something wrong. We should go back and
redo that one
later. We'll
Okay.
do that later.
So I'm not gonna make a comment on the voltage yet.
Yeah.
I'll just put a little voltage question mark, and I'll make a note to come back to that.
I like that.
Okay. So let's go ahead and go. You know, these things happen, right?
We'll go to 2 batteries.
Oh, two batteries. Okay, so you know what? I think we might have had the batteries going. I don't know. Okay, so you ready for this, guys? And
Okay, it's
Oops.
definitely brighter,
definitely brighter.
and we've got about 3 volts, and we've got about 90 milliamps.
Okay, so 3 volts and 0.090 amps.
Yep.
What's our question here? Oh, and it was definitely, I'm going to say brighter than number 3, right?
Yeah.
Trial 3. Okay. What was the same? What was different between trials 2 and 4? Okay, so trial 2 is this one up here.
Yeah. Well, there's 2 batteries and 1 bulb in each one.
But you can see that the current in trial 4 is a lot less.
Yep.
So trial 4 current is less than trial 2. Okay, talk to me about the voltage here.
Well, the volt's a little bit more.
A little bit more. Okay, so I'll say and voltage is more. Okay. What about the brightness? I can't really say much about the brightness. They are both brighter than with just one cell.
Let's do this. Let's hook both up. We'll do them in parallel.
Oh, okay.
Let's hook both bulbs up to the,
Like this?
yeah, and let's just see which one. Take the voltmeter off
Oh yeah, okay.
and take, all right. Okay.
So that way we can kind of see which one is brighter. So this will be
Okay.
trial 2, that's trial 4, the trial 4 light bulb.
All right, hang on a second. Let's do this. Let's take these 2 off, and let's bite this to 1,
Like
and then,
get in there. Bada boom, like that.
okay, and then let's take this off, bite that there, and
Get on there, buddy.
bite these 2 together.
Oh yeah, I see.
And now, put these side by side, and let's see which is brighter.
It looks like the round bulb, right?
The round bulb is definitely brighter than
Okay.
the oblong bulb.
So
Let's do that with 1 battery. Just do it with 1 battery. See.
Yep, still the brown one. Can you guys see that? I hope you can.
Yeah, the round one is still brighter than.
Okay, so what was different between trials 2 and 4? Then do I want to add in that trial 2's light bulb is brighter, right?
Yeah. The round bulb was brighter than the oblong bulb in both 1 battery and 2 batteries.
Must be something up with the bulb.
Something going on with that bulb, dude.
Okay, let's go back to the voltage. Let's go ahead back to the trial 1.
Yeah, let's just take a look. Unbite these guys here and those guys.
There we go.
And let's hook the voltmeter across the bulb without the ammeter.
Okay, get this there then. Okay.
See, because I think we got 1 volt across the bulb in that first trial. All right, let's see what we got here.
Okay, here we go.
Huh.
Weird, right?
Yeah, that only brings it up to about 1.1 volts. It is what it is, boys and girls.
All right. So, we're gonna keep this. You could put 1.1 if you wanted to. I'll put 1.1. And down here, we're gonna come back to this. What was the same? What was the difference between trial 1 and trial 3 in terms of the voltage? Do we want to say anything about that, or should we ignore it?
Well, no, it's different. You know,
Yeah.
it's not very different, but it's different.
So we'll say voltage is more in trial 1. Data doesn't lie. We just got to go with the data, right?
Now let's look at the next page.
Okay. All right. So here it says transfer your data into this table. Okay. So that means, so we've got all these different trials, 1, 2, 3, and 4, like we did on the previous page. And we've got the current, the voltage. We have the current, we collected the current and the voltage, right?
Yeah.
So let's go ahead and just transfer these over. Should we do this with them right now?
Well, no, they can do that on their own. And then you're going to calculate the power, which is the volts times the amps. And then here's a simple thing. We're just going to take your number for the potential difference and divide your number by the current. So make a fraction with the voltage on the top, the current on the bottom, and then equals. And let's find out what that ratio is.
I'm gonna do the first trial with them, and then I'll let them do the rest.
Right.
How about, just so they can see it, okay? So trial 1 is 0.160 amps, and the voltage for that one was, well, I should have kept it as 1, is 1.1 volts. And if I wanted to calculate the power, that's easy. I just multiply through 0.160 times.
Should you show your work, Miss
1.1.
Moore?
I totally should. Thank you for catching that. So power equals, so I'm gonna say 0.160 times my voltage, 1.1 volts, and I get we're gonna call it 18 watts. Okay.
Okay, now that.
And you're gonna see the things aren't right. Okay. So now I'm gonna take that my potential difference here, which is just 1.1 volts. I'm gonna divide it by my current, which is 0.160 amps. And I'm gonna get an answer here. So 1.1 divided by 0.160, and I get, we're gonna call it 6.9. Yeah. So 6.9 volts over amps for right now.
So do exactly the same thing with the other trials. Here's the data. Fill out that table.
Okay, and then what's our last part say here? Using the correct, that's for the next day, right?
Yeah.
All right, so that is the first part of our changes lab. And do that for homework. Finish up that data. You should have collected information on ammeter readings, voltmeter readings, and bulb brightness. Okay, so now along with finishing up the calculations, answer these questions as well. Why, this is your first one out of 3, why is each bulb brighter when you put a second battery in the circuit?
That sounds familiar to me for some reason.
I think we've talked about this before. Yeah. Okay, what is the relation between how bright the bulb is and how much current flows through it?
That's an easy thing. All you got to do is look at your data.
Okay, and then why might more current flow through one bulb than the other?
Think about this.
This one we haven't really touched on yet, but we want you to kind of come up with some ideas.
Yeah.
What could be going on here? What
All
was
right.
the only thing that changed?
Yeah.
Okay, good luck.